Awesome. Well, welcome everyone. My name is James Serra. I'm a data and AI solution architect at Microsoft. I've been here 10 years. I work in the federal civilian a part of Microsoft, working with US government customers. So quite an interesting time, a separate topic for discussion. A lot of what I talk about in this deck is what I go over with customers on there. A lot of confusion about all different data architectures and how Microsoft Fabric is used as part of those architectures. So hopefully this presentation will clear some of that up. A little bit about me. I've been doing this quite a long time, 40 years now, and have had all sorts of different roles, but the last 10 years have been focused heavily at Microsoft on pre-sales, where I educate customers on all things Azure, focus mainly on data products such as Fabric and Purview, and also educate customers a lot on the data architecture is the big part of this topic, which is where I will cover the agenda here, which is double check people can see this. I got a couple of notifications. Okay, yeah, so sometimes you have to exit and go back into Teams. And there I love to say Teams is perfect, but I've seen this every once in a while. So the agenda is I'm going to cover at a high level what a relational data warehouse is and a data lake, and then I'll get into the four architectures: modern data warehouse, data fabric, data lakehouse, and data mesh. And then along the way, and at the end, I'll talk a little bit about how Microsoft Fabric works with these various different architectures in here. And I have to say that these are my opinions and not that of Microsoft. There is a couple slides where I'll talk about the official opinions of Microsoft, but in general, most people agree with me at Microsoft on these particular architectures in there, but it's not set in stone. So if you go back to your work and say, well, Microsoft said this, no, it's really James Serra said this. So I just wanted to clarify that. And I also wanted to say, you saw my email address, and I'll have it at the end. If you have any questions, post them in the chat, and I'll try to cover them at the end or during the session. And if there's anything I didn't get to, just feel free to email me, and happy to answer those questions. And I think some of you will feel like this person here, try to understand those architecture stuff, and you feel like you're winding up passed out Johnny's and Denny's parking lot. Now, I know some people are outside the country, so they may not know what a Denny's is, but essentially it's kind of a low grade breakfast place in here, and so that's not me. I had one person ask me if that was me, and no, it's not. So let's try to prevent that from happening. So talking about a relational data warehouse at a very high level. Why do you have a data warehouse? And I still get people asking me this question in here. And the whole idea is to take data from your various OLTP type of sources, operational data, and copy it into your data warehouse and have that be the single source of truth, that central repository that has many different subject areas. You could have dozens or sometimes hundreds of data sources that are copied into the data warehouse. At what point you'll use reporting, visualization, machine learning on top of the data sitting in the data warehouse in there. And the bottom line is you're just trying to make better business decisions. You want to get greater insights to your company, and you can do that with data. Also important to know that you're always going to need a copy of the source data. So if you don't, even if you don't have a traditional relational data warehouse and you're using one of the other architectures, you're going to copy the data. There's a myth that I've heard people say, well, with data mesh and some of these new architectures, you don't need a copy of the data. Well, that's not true at all. You're always going to have to copy of the data. It's just trying to reduce the number of copies of the data. And some of the newer architectures help with that, but you're still going to have at least one copy of the data. Why have a relational data warehouse? There's a lot of reasons in here. I'll just list a few of them. One of them is you have the single version of the truth. So the idea is you don't want to have different answers to the same question here, and correctly building a data warehouse allows for that. You want to reduce stress on the production system. This was really the reason data warehouses came about in the first place, was people were running reports, especially long-running reports on the operational system. And meanwhile, people are trying to update, delete, insert. Maybe it's a customer database, customer product that they're using in there. And because the reporting is overwhelming the compute, they're having problems with timing outs and things like that. And so the idea was, we'll copy the data over into a warehouse and do that heavy compute reporting on the data warehouse and reduce the stress on the production system. When you copy it over, you can also optimize it for read access. I can put all sorts of indexes on there that make it a lot easier and perform it to run the reports, something that is difficult to do in a source system because it's optimized for not just read, but updates and deletes and inserts in there. And so adding a read access, a read index in there could cause problems with those updates in there. Where relational data warehouse, it's write once, read many, so you can put a lot of read indexes on there. Also, it's very challenging if you're doing reporting on a source system. I've seen table names that are T116, very difficult to understand. You want to have self-service BI. Well, to do that, you need to make it easy for end users to report off the system. And you can do that by making the table and field names very easy to understand. So if your source system has those strange names, when you copy the data over and create tables in the relational data warehouse, you can make those names much more easier to understand. So that's another big plus of relational data warehouse. Also, and I've seen this a lot when I was a DBA for many years, if you have all your reports running against a source system, an application, and that application gets upgraded, and maybe you have dozens, if not hundreds of people who use Excel against that application, and the upgrade changes table names, deletes them, and all of a sudden all those Excel reports break. With a relational data warehouse, if you copy the data into the data warehouse, you're protected against that happening. The reports run against the data warehouse. Worst case is if they update the application, the ETL may break, but you just got to fix that one spot and then not have to go and correct all those reports. So that's a big plus. You'll find as you copy the data over a lot of problems with the data. It's got to be cleaned. As an example, maybe birth dates are empty or people are 200 years old. As you find those problems, you can report back to the application teams that there's these problems where people are bypassing birth dates in there and they can fix them. Now you still got to go and clean up the data that's already been transferred, but you wind up finding bugs and plugging those in the source systems. And then, as I mentioned, to get that self-service BI, as an IT person, you don't want to spend your time writing reports and having a backlog of end users constantly requesting all these different reports in there. So if you build out a relational data warehouse and do it the right way, you can have the end users build those reports and take that work away from IT systems. All right, so that's a relational data warehouse. Now a little bit about data lake. The idea of a data lake is schema on read, meaning I can copy data into a data lake and not to do any upfront work to get that there, as opposed to the relational data warehouse, which I just went over, is schema on write, meaning I have to go there and I have to create a database. I have to create the tables and the fields and write the ETL. So it's a lot of work to get data in there. A data lake is a glorified file folder. I can just do a copy and paste and get data in there. And that also allows me to put any kind of data, not just structured data that you see in a relational data warehouse. I can have video and audio files and drop it in there. So a data lake is all encompassing for all types of data, and you can land it in the raw format. So what's the benefit of having a data lake on there? I just went over this, that the quickness of it, you can land data in there. Now there's always drawbacks to all that, which I'll cover in there, but the idea is, especially for technical people, you can land data in there and they can quickly start doing reporting off of it. They don't have to wait for somebody in IT to go create that database and tables and fields in there. So that's a tremendous benefit. This used to be a challenge. You had to have some technical knowledge in order to make use of data in a data lake. This is greatly enhanced now with products like Data Fabric, which hide a lot of the complexities and make it easy for a non-technical purpose person to pull data out of the data lake and use it in there. And Fabric is all based on a data lake, and I'll talk a little bit more about that. But going away is the relational data warehouse in there. And I'm kind of spoiling a future slide in there, but data lake is what I see almost all companies using when they're building data warehouse-like solutions in there. Because of another reason where it frees up the resources that you use inside of a relational data warehouse and removes the need for a maintenance window. As an example is, typically with a relational data warehouse, you have a maintenance window. You, at night, knock everybody off, say at midnight, and then you start loading data into the relational data warehouse and you're transforming it. And you have to knock people off. That's because it's very compute intensive. You can't have people trying to run reports while you're doing all this. They also may get incorrect results and while the middle of the transformations are going. And then you cross your fingers and you hope by, say, 8 a.m., all that transformation is done, and then you'll let people back on there. So and you do that by loading data into staging tables in a relational data warehouse, clean it, and then you copy those into the production tables. So think of a data lake. A big feature of it is take those staging tables out of the data warehouse and put them in the data lake, and you do all that transformation inside of the data lake. A data lake is just storage. You can choose, and it's very flexible on what compute you want to use to transform that data. And you do all that outside of the relational data warehouse, so that could be going 24/7. You don't have a maintenance window other than maybe a 5-minute window where you copy the data into the production tables after it's been transformed, but all that happens outside of the data warehouse. And this really became popular as people started wanting to have the data warehouse be 24/7, and they needed to get rid of the maintenance windows, and the data lake allowed for that. Because you could have multiple compute options on there, it allows you to have an environment where you can save costs by using cheaper compute. If you're using a relational data warehouse, you're locked into whatever that data warehouse has as far as compute. With this data lake in there, you can use any type of compute. You can even say, well, I'm willing to spend more money, and I may have a huge cluster of compute that will transform this data faster than I'm willing to pay for it, something that you couldn't do with the relational data warehouse. You can also stockpile data in a data lake because it's very cheap, especially relative to the cost of a relational data warehouse. In addition, they have features like tiering in Azure where you can have data in archive, cold, colder, or hot, where you can move it to one of these other type of tiers and save a lot of money that way in there. So it's a great way to stockpile data, whether you are not sure if you're going to use it or not, which is very different than a relational data warehouse. Generally, you're limited on how much data you can put in there, and you can affect the performance by having a lot of data in here. With a data lake, you don't have to worry about that, and it's unlimited. A data lake in Azure, there's no ceiling of how much data you can put in there. All right, so that's a little bit about a relational data warehouse and a data lake. And now I'll jump into the 4 architectures. And the modern data warehouse is the first one that's been around for quite a long time. I would say we first started seeing this in the relational data warehouse came around the 80s, and the modern data warehouse, I would say in the late 90s came about. And right when data lake was first announced, late 90s, maybe 2000. And the modern data warehouse combined the relational data warehouse and the data lake that I just talked about into one architecture to give the best of both worlds. The idea being, as I mentioned, you put the data, you ingest it into the data lake, and you store everything there, you transform it there, And that may be enough for data scientists to start doing machine learning on that data lake. But most of the end users would wait until the data is copied into a relational data warehouse where it's modeled, and then they can do their reporting and dashboards off the data in a relational data warehouse in there. So you had an extra copy of the data, and this was done for performance reasons in a relational data warehouse again in there, because at least early on, a data lake wasn't really good at performance that was needed for most types of reporting. So having both and the best of both worlds is kind of listed here. In most cases, customers would use a data lake for staging and prepping the data, as I covered before. And the relational data warehouse was used as that serving and security and compliance layer in there. So most end users were going through the relational data warehouse in there because they needed the extra performance, because they maybe had a lot of users that would overwhelm the data lake, but not so in a relational data warehouse. And the other reason, the big reason too, was the extra security you get in a relational data warehouse, because a data lake doesn't support things like row-level security or column-level security. And if you need those things, you're only going to get them in a relational data warehouse on there. So a lot of customers said, well, the data lake's only going to be used by admins to set up the jobs to clean the data, and then everybody else is going to use relational data warehouse as the serving layer. And this is what it looks like at a high level. Is you have the data sources. It could be unstructured and semi-structured data like CSV files, and then relational databases. All that is ingested into your data lake. And the data lake, if you've heard of medallion architecture, you have gold, silver, bronze, or I like to call them raw, clean presentation layers on there. The idea is the data is going to move throughout the data lake. It's going to land in raw. You're going to clean it, put in a clean layer. Then you may aggregate it, master it, join it, create a star schema, and that's going to be in the presentation layer, which may be enough for your data scientist to use it. But most times you're going to copy it to a relational data warehouse, in which it may land in there in a third normal form, but then you create a star schema and then you visualize it. And this was the way Synapse was used as an architecture on here. The Synapse has your dedicated pools. That's your relational data warehouse. And the Synapse also supports data lake in there. So as customers were using Synapse, they were following, in most cases, the modern data warehouse architecture. Again, this has changed, but it gives you a good understanding of how we got here and why the way we do it now is better than prior architectures. The data fabric, and this is where my view may differ than others, but I see the data fabric as an evolution of the modern data warehouse. It's taken that modern data warehouse and adding additional features. Those features include things like real-time processing, mastering the data, maybe using a virtualization product on there, additional security, metadata catalog using something like Purview, maybe creating APIs to access the data, and maybe building it out in building blocks so that people can say, well, I don't need the data fabric you built, but you have a great ingestion piece, and I want to use that for something else in there. And so the data fabric term has gotten pretty popular now, and it's called fabric because you can think of it weaves it out into your environment and finds all the data and ingests it and cleans it, and therefore it's like a fabric in there. And diving into what that looks like at a high level, you'll see in purple are some additional features that were not on the modern data warehouse in there. Things like a metadata layer and additional security and mastering the data on there, and then maybe creating APIs. And if I dive into what that looks like at a little bit lower level, you'll see it's very much like the data warehouse, but we just have more features on here, including streaming. So real-time ingestion of data is part of a data fabric. Additional security is on here, API calls, and again, this was what Synapse did very well. I've seen very few people now mention the modern data warehouse. Usually they call everything that's using a relational data warehouse as part of the architecture data fabric now. Data fabric is defined much differently by some other organizations like Gartner. I go more of that into my book, but in general, think that a data fabric also has that relational data warehouse component because that's what's really changed in the next architecture. And then that next architecture is your data lakehouse. A little bit of history that helps you understand a data lakehouse architecture in there. When we started in the 80s, and that's when I first got started, you may, for those my age, may remember products like Teradata, obviously all on-prem, and that data product would be all-encompassing, meaning it had the relational storage, it had the compute, it had the reporting, it had the ETL, and those worked very well. Of course, big data back then was a couple of gigabytes, and a lot of times customers would have an enterprise data warehouse and they would copy some of that data into the data marts. And you may remember, some of you, the arguments and debates between Kimball and Inman, which still happens on there, and those became talking points of how proper to build out a on-prem data warehouse solution on here. Well, the internet came around, and that made it very challenging to capture all this data from the internet into an on-prem database. It just wasn't possible or feasible in many cases on here because we now had access to a whole extra ton of data. And that's where the data lakes came about, was because especially in the cloud. Now, at first they were on-prem, but they were a lot more scalable and allowed you to put all sorts of data. It could be social media, IoT data, or just the fact that the internet allows a lot more collection of data, and that could be stored in the data lake. And a lot of that may not be structured data. So data lakes came around as the be-all, end-all. Now, what happened, and you remember there was a lot of companies like Horton Royce and Cloudera, and all of them are gone now except for Cloudera, and it's because of the data lakes trying to be too much. I still remember dealing with customers who said, we don't need relational data warehouses anymore. We can just do everything in a data lake. And I would fight back and say, well, a data lake is very challenging because the technology is difficult for everyone to use. And the customers that still proceeded to create a data lake, it always failed because it was too much to have everybody use that technology, especially when they use relational data warehouses. So they didn't get rid of data lakes. Instead, it morphed into the modern data warehouses we talked about. Let's use data lake what it's good at, transforming data, and let the relational data warehouse do everything else on there. And that was the solution for maybe the last 10 years. But then around 2020, Databricks came out with what they call the data lakehouse. It's the idea of combining a data lake and a data warehouse into one storage solution and doing everything in there, which you should be thinking, well, wait a minute, you just said that didn't work with the data lake, because the data lakehouse is getting rid of relational data warehouse and putting everything in a data lake. So what's changed? Well, what's changed was Delta Lake. This is a technology to put on top of your data lake to give it relational data warehouse-like features, such things as supporting SQL commands. A data lake on its own has no idea what SQL is, but a Delta Lake with that software layer allows you to submit SQL queries to it, or update or delete statements, and use that against files sitting in your data lake. Those files are in Delta format, so products have to support that, which pretty much everything does now, but it gives you these additional features in there. And ACID transactions, for those familiar with what that is, it's very important to have consistency in your tables, and Delta Lake gives you that. It also allows you to do versioning or time travel, which is really helpful for rollbacks or auditing. It gives you one platform for streaming and batch unification instead of using different products for either of those. Delta Format and Delta Lake support both of those. You also have the option to do schema enforcement. It was always a real pain when I would set up a solution and I would pull data from a folder and the data needed to be in a certain format, and somebody would drop a invalid format in there and the ETL would blow up. Well, now with Delta Lake, you can say, if it's not in this particular format, reject it and won't let it put it into that folder, something that's just not available with a normal data lake. And then you had a lot of performance improvements. There's dozens of them. And that solved, in most cases, the problem with data lake being too slow to use for reporting. With Delta Lake and these performance improvements, it allowed it to be used for reporting directly off of it. And then for those familiar with a small files problem, which was a big performance issue, Delta Lake also solves that through this optimize command. And it's very easy to set Delta Lake up. If you're using Spark, instead of saying, I want the format to be Parquet, you just say Delta, and that's it. So it also got very popular because of ease of use. Now, underneath the covers, when you say Delta, it stores it in Parquet format with a Delta log in there, but that complexity is hidden from you. But the trade-off is a product needs to know about Delta Lake in order to read and write data to it. And so what that architecture looks like dropping down a little bit deeper is just like the data fabric, but we removed that relational data warehouse component in there. So there's only one copy of the data through what's in yellow, that Delta Lake in there. So this was a big benefit, and not having to have two copies of the data. And it solves these 6 problems in there. If you had 2 copies of the data in the data lake in the warehouse, you got to keep them consistent. And if ETL broke, you're in trouble. The data in the warehouse would always be older. Even if you're running at, say, once every hour, you could have different answers to the same question, depending if you're going against the data lake or the relational data warehouse. Data scientists generally prefer files instead of structured tables, so they like the Delta format for that reason. 2 copies of data, even though it could be pretty cheap, and you're saving 50% off by only having 1 copy of the data. And having an additional copy opens up to more security risk, and that's minimized by reducing the amount of copies in there. And the big reason is, if you have both the relational data warehouse and the data lake, you need to have people that know both, or you hire people that are specialized in both. Now you only need to hire people that know one technology, and that's Delta format. So diving into what that looks like is listed here. And this is a lot like Data Fabric, again, without a copy of the data in a relational data warehouse. Now, I list here a relational serving layer because you still want to give the appearance to end users that they are using a relational database, that there's a model, and that model could be a third normal form or a star schema. It could be a semantic model in Power BI. The idea is to not make it complex for the end users, where they're going in and they're just seeing folders and files. That's too much for them. So you have a serving layer that sits on top of those files and folders, so they think they're actually using relational storage, but in reality, it's just a model where it's pointing to the files in the Delta Lake. And this is where Fabric, this is the way it works. It uses a data lakehouse in the background. It no longer has any relational storage like you had in Synapse. And this is what that looks like in Microsoft Fabric. Is if I label all those pieces, the data lake, which is in Delta format, is one lake. In Fabric, you do not even realize you're using Delta format. You just see one lake, but underneath the covers, and that's hidden from you, but you can go and view it, is Delta format, which again is Parquet and a Delta log in there. And the medallion architecture, the cleaning is all still the same. That doesn't go away. This doesn't get any easier. There's still a lot of work done in cleaning and governing the data. But you have additional options with Fabric. So listed on that bottom right is I can clean that data. I can use Spark notebooks. I can use T-SQL sort of procedures. I can use Dataflow Gen 2. And that data eventually goes to the presentation layer or the gold layer. And then you have your semantic models on top of that, in which you make it easy for the end user then to go and build all the reports. All right, so everything's got trade-offs. And I always tell people when somebody says this architecture, this product is great, you always got to go, well, what are the trade-offs? Because there always is some. And so what happens when you don't have that relational data warehouse? Well, you're not going to get queries run as fast because the data lake or the relational data warehouses have always had, for many years, functionality features to make it go very fast. Things like massive parallel processing, advanced indexing and statistics, caching, query plans. A lot of these don't exist in a Delta lake, or they do, but they're more basic. So you'll never get, I shouldn't say never, but you're unlikely to ever to get queries run as fast on Delta format as a relational storage on here. As I mentioned before, there's no row level security, column security, dynamic data masking. These things don't exist in Delta format. So if you need that, you may want to look at a relational data warehouse, but hold off on that as I'll talk through workarounds for all this. People are used to a relational database. The one good thing about a relational database is, yeah, it's schema on write, it's extra work, but that could be a benefit in that you are getting rid of that complexity of having a file-based folders and files, and you're forcing the to have metadata on the actual data. Because a challenge could be in a Delta lake, as I can drop a CSV file in there, and it may not even have any metadata. It could not have headings in there. So how do I know what it is? That's a big challenge. In a relational data storage is you have to have metadata on there. So you're forcing it. So you can get around that by forcing people to have, say, headers in a CSV file. Or as you'll see, using a product like Fabric helps prevent this in there, but keep that in mind. It could cause a lot of confusion. Concurrency could be an issue. A Delta format doesn't do well if hundreds of people are hitting the same file, where relational data warehouse is kind of built for that. And then there's some missing features that you just don't see in Delta format, like referential integrity. And then finally, the products obviously must support Delta Lake in order to use it. Fortunately, just about everything does now. Now, there's some competing like Iceberg and Hootie, but those are combining in newer versions to be able to use any three of those. And those are essentially just like Delta Lake. They just store the formats differently in there, but all these concepts still apply. The good news is Fabric and along with Power BI addresses most of these concerns in there. For example, rule of security, I can do that in Power BI. I can do that in Fabric. They're coming out with one security soon that will allow you to do that on the data, and it applies to anything that tries to access the data. Concurrency with Fabric having direct lake or import mode gets around concurrency. So 90% of these things are taken care of with Fabric, but if you're not using Fabric, you should be aware of these. And that gets us through the first three architectures in there. So again, drop any questions you have in the chat. I think we're good. I don't see anything in there. And now jumping to the fourth architecture, data mesh. This was originally created by Zamek I think it's been 4 or 5 years ago now. And one of the challenges I had with trying to understand data mesh was it was just written to be difficult to understand exactly what the difference between a data mesh is and a traditional method. So I've created this slide. Hopefully this will give you a high-level overview of the differences. The three architectures I talked about are all about taking operational data and copy it into an analytical data solution, a central data warehouse, whether that's a lakehouse or relational storage. Where data mesh is different, it's decentralized, meaning you no longer copy that operational data to a central location. Instead, each domain will create the analytical data. Each domain would have their own data warehouse or data lakehouse or data fabric on there. But they're going to make those analytical data easily available through data products so other domains can easily grab that data and people can combine the data from all. So it goes from centralizing the data to decentralizing the data and pushing the work to each domain to create the analytical data. So you're not getting rid of a central data warehouse. You're creating local data warehouses, many of them, inside of each domain. That's it at a very high level on there. But data mesh is a concept. It's not a technology. If you read your book, there's nothing about technology in there, and it's a huge organizational and cultural shift. At the previous slide shows, now you're having all the domains do everything. And even setting up things as domains is a big shift because it involves change and people moving. And that's where honestly 99% of companies don't go a full data mesh because people are very resistant to change, and it's really hard to get a huge organizational shift. Data mesh is not a magic wand you can buy on eBay. It's if you go down the data mesh route, it's going to take a lot longer to build a solution. So keep in mind there are no shortcuts, and data mesh, despite a lot of the hype, is a lot more work than the three other architectures I talked about. Now, explaining data mesh briefly at a high level, it has four principles. The first one is domain ownership, meaning we're not centralizing the data. We're keeping it all in these domains. So we got to build out these domains. Maybe we have domains like manufacturing, sales, and supplier. And the benefit of this, at least in theory, is that the people who are in those domains know the data best. So they should be the ones that clean it and do all those things to it, as opposed to trying to get IT to do it, where they could make mistakes. Now, because each domain is now keeping that analytical data and creating and keeping it there, to make it available to other domains, they have to treat data as a product. And so the domain team are going to create their own internal IT teams, which are going to write API code, maybe, to access the data and the metadata. They're going to build out the infrastructure, and they're going to do a lot of work to make data easily ingestible by people outside of their domain. Now, if you're creating dozens, if not hundreds of domains, that could be quite challenging because you're now pushing that work on each domain. So what you can do to help them along the way is principle 3, is self-service data infrastructure as a platform. The idea is, well, ideally you create a script and you just ask, what is your domain name? And it goes out and builds the infrastructure. It builds the storage and the compute and the ETL and the security. Now, obviously there's nothing that can do that or even come close, but maybe I can create some scripts or some frameworks as a central IT team that can make it easier for the domains to build their solution. So a common misconception with the data mesh is that everything is decentralized when it's not. Everything is. The data is, but principle 3 and 4, you have a centralized team that's going to write those scripts and help the domains to build out their solutions. And bringing us to the fourth principle is you don't want to have each domain just going and doing their own thing as far as security. So you need to have rules set up by a central IT team that's going to tell all the domains, hey, please follow these rules. We can't have different security methods. We can't have different ways of cleaning the data. You have to follow these regulations. You have to do this modeling in a certain way because people are going to need to combine the data. And so to reduce the challenge of that is you should have these defined rules that everybody follows. So those are the four principles at a high level. And this leads to the use cases for a data mesh is to solve four of these challenges that you see with the other architectures in there. Is, as I mentioned, the ownership is by the domain team, so it gets rid of that common argument over who owns the data. If it's copied to a central location, is that data owned still by the local domains, or is it owned by IT? Well, that goes away because there is no central copy of the data anymore. It's owned by the domains. The lack of quality of the data is a problem if you're copying it to IT, who may not understand the data and they don't clean it correctly. So that problem goes away. And then the two biggest issues that are taken care of with a data mesh is scaling. If you have a central IT, they can become a bottleneck because of people-wise. You adding more and more data to the central location, and they just don't have enough people to ingest it all in a timely manner. And then technical scaling, if you have, again, a central IT solution and it's one technology platform, it could be very challenging for that technology to keep up with all the data you're trying to ingest. With a data mesh, the more domains you have, the more people you hire to create the analytical data in there. And so you solve the problem with not enough people by scaling out organizationally, horizontally, and you also scale out technically because each domain has their own infrastructure. So the more domains you have, the more infrastructure, the more people you get, and you solve the scaling. What does the domain look like? Here's an example in healthcare, and this is where it can take a long time for people to set up. A huge challenge is I'm going to have domains, and I'm also going to have products within those domains. So this gives you an idea of what a healthcare company will look like, but you have to do this for each of your organization, and this could take weeks, if not months, to set up. The data mesh type here, most people use the mesh type 2, which is, well, let me start out with the pure data mesh type 3. The way that which nobody is doing type 3, and these are my definitions, is a domain can use whatever technology they want, including storage, and this nobody is gone down that route because think of the complexity of having one domain using Azure, one using AWS, one using Google, different securities. So what people have done is they have exceptions to the data mesh, and some of them may have mesh type 2, where each domain uses the same technology, but they also have their own data lakes and data or delta lakes or different storage components in there. So this could be challenging now because if you can combine that data, all these data lakes or delta lakes have to be queried and combined. And those data lakes could be all over the country, if not the world, in there. So most people use mesh type 1, and that's where Fabric comes in there, where they're all using the same technology and they're all using the same data lake, in this case, one lake on that, which logically separates out the data. So it appears to be separate data lakes, but it's really just folders within one lake, and that helps with performance and governance. If you were listening intently to some of my slides on data mesh, you're probably like, well, wait a minute, I can see some concerns with a data mesh in there. And there's a whole bunch of them. And I list a lot of these in my book, and call out a few here is, you probably first said, well, wait a minute, that's a lot of organizational change. You now have to go and get each domain to build their own IT team. You may get a lot of pushback from the domains to say, look, I can barely keep things running now. I'm not going to now create an analytical data in a data warehouse in there. So that's a big problem, especially when it's so hard to find good engineering people. And so what incentives are you going to give those domains to go and do that extra work now? And if you just say, well, for the greater good, that's generally not going to be enough in there. So you have to get a lot of buy-in, and that could be very challenging. And then also, if each domain is doing their own thing, who is looking out for the best way to combine all that data? So this gets really difficult because people may not care outside of their domain how people are going to use the data, and that's going to lead to it making it really difficult to put it all together. So the way I see the data mesh future going is, first of all, there's a lot of exceptions, which I'll talk about in a second in there, but the idea would be you're going to use more centralized, you're going to take your centralized approach because most of the time you're migrating, and you're going to, starting to see companies now, they'll create a data mesh, but only do it for new domains. And so it's a hybrid approach, a hub and spoke approach on here. And maybe over time, they'll move some of the centralized into a data mesh, and they'll get some benefit, even if they're just a couple of spokes in there, because those are less work for IT on there. So this is where I think it's going. You'll see a combination of a centralized and an outside data mesh. So when to use each of the architectures. Modern data warehouse, I still see every once in a while if you have a low amount of data. Now, maybe you can even skip the data lake if it's just a couple of gigabytes in there. But always think of the future, and what works now may not work down the road. So always keep that in mind in there. Data fabric, I generally see only in cases where people have to migrate data, because getting rid of a relational data warehouse could mean a lot of changes to T-SQL, because certain things are not supported if they're not going against a relational data warehouse in there. And if you've created hundreds, if not thousands, of stored procedures, and you want to get your solution on-prem into the cloud quickly, you may say, I need to reduce the amount of work, and I'm going to use a data fabric with a relational data warehouse, so I don't have to rewrite many of those stored procedures. But data lakehouse is the future, and I always say use it until you can't. If you find you don't get, because of those trade-offs I mentioned before, you don't get the speed you need, maybe you have a billion rows in this one particular table, well, just copy those billion rows to a relational data warehouse and work off of that for that particular set of data. But it's not an either or. Everything else could be in a Delta format in a data lakehouse, but a particular set of data could be moved to another storage to make the performance better. And then finally, data mesh is only if you have a really large company that's having major pain points, and including with scalability, and you have a very long timeline. Other than that, people will use data mesh. They'll call things a data mesh, and it's not really a data mesh. It's more like a data lakehouse. In the end, most companies are using bits and pieces of each of these architectures, and that's why I tell people, learn about all of these, and then choose what's going to work best for your use case on that. And if you like the word data mesh and you want to call it that, even though it's really not, I don't have a problem with that. All right, so one question by Arno. What I've never understood about the data mesh, how it solves a scaling problem. The fundamental assumption is scale out resources, people across the org, but the actual investment needed to realize the scale out would probably solve your central bottleneck in the first place. Great point, and that's what I talk a lot about in my book, is that it sounds great in theory, scaling out, but it's very, very challenging. And when I interviewed customers who built out a data mesh, I found a big example, or exception, I should say, with most of them, was they still had a central IT team building everything, which kind of defeats the whole point of scaling. And even with Zamek in her book, and so see future blogs in there, she talks about how you can do sort of workarounds by having domains that combine data from multiple domains in there. They call it aggregate domains. But to me, that defeats the whole purpose, is now you're centralizing the data. Well, who owns that? And who's going to build that? And now you're getting back to the centralization again. So this is one of the reasons why data mesh never, at least the pure data mesh, has never become popular, is just because scaling out sounds easy in paper, but it's very challenging. And you can also say, one point I disagree with her is she's sometimes you're trying to find a problem that doesn't exist, and that is, well, none of the solutions today can handle large amounts of data, when in fact they can, and they don't need a data mesh because the technology advanced. And I've seen plenty of companies that have petabytes of data that are centralized in it, and so it can work with the current technology. Now, Microsoft's position, this is the official position, is is that, hey, we don't care what architecture you use, but just follow some good principles. And the thing called Modern Analytics at Scale, or MAG, is what Microsoft has a playbook that you can follow to build a solution, no matter what's data mesh or data fabric. So Microsoft pushed calling it MAG at scale instead of data fabric or data mesh. I don't actually see many people taking that approach in there, but they do follow this analytics governance at scale. And there's a couple of links here you can use because it talks a lot more about just the technology. It talks about culture transformations in there, whether you're building a data mesh or a data fabric or a data lakehouse in there. So there's a lot of good information in these. I put some of the links to the white paper as well as the technical aspects. Microsoft has a thing called Cloud Adoption Framework and Cloud Scale Analytics that talk about how to properly build out a data mesh or data fabric. And so you definitely want to check out those links if you're looking to build a data warehouse-like solution in the cloud. There's a lot of exceptions to pure data mesh. As I said, nobody's built a pure data mesh. Nobody ever will. The common exceptions are listed here, and that is using Microsoft Fabric for each domain. Instead of having them choose their own technology, everybody standardizes on Microsoft Fabric. And instead of having APIs to pull data or metadata, each domain, the way that's done is through shortcuts to each domain on there. Microsoft Fabric, it's a great feature, shortcuts. If you're not familiar with it, it's kind of like a virtualization layer, so you don't have to copy all the data. Now, there is trade-offs with performance in there, but a lot of technology in Microsoft Fabric minimizes that. And you can set up domains in Fabric, but they're not enforced. I can put anything in the domain. So you really need to be very stringent on what you call a domain and not have it vary across different products on there. And I also want to mention that data mesh has 4 principles on there. So you only have a pure data mesh if you're following all those 4 principles 100%. Many customers are calling something a data mesh, but they don't follow but maybe 1 or 2 of the principles. So can you really call it a data mesh? And they're following the data mesh maybe 50% and the 2 principles in there. So that's where there's a big gray area. And Zamek in her book calls data products using a data quantum. It's a very challenging way to build a solution, and she's working on her own company to do that. But I haven't seen anybody build out data products like she talks about in there. Usually data products are just a semantic layer in Fabric, and that's your data product, but it goes very much against what she talked about. And there's some links here, and in particular one in Zamek just came out where she talks about all the exceptions to Fabric, the anti-pattern she called, and the people are using them to build out a data mesh. And OneLake is a great solution for building out domains because you can create a domain like sales, and then you specify all the workspaces that are part of sales or part of marketing and finance on there. Again, it's not enforcing anything, but it gives you the ability to set up domains and then have people use those domains within Fabric. And so you can think as having those shortcuts, as I mentioned before, as allowing you to only have 1 copy of the data. And that is a huge benefit if you're building out a data mesh or even a data lakehouse in reducing the number of copies of the data. Again, there's trade-offs to all that, but OneLake has minimized a lot of that. Here is how you would go into Fabric to create your domains. And you have subdomains supported now a few months ago. I list here that this helps with, if you go by these exceptions, you're going to say, you can look at now and say, well, I've solved some of the challenges with the 4 principles in here with those exceptions. And I can have medium level domain ownership and product, maybe a high level and self-service infrastructure platform because everybody's using the same platform. I still have the challenge of computational governance on here, and that's where Purview comes into play, as that product that could be used to help govern all the domains to make sure that their data is secure and they're following governance rules that you've set up. And you're avoiding data duplication by having everybody catalog what they're building out on that. Now, it gets challenging if you look at the way Purview organizes things by domains, what we call business domains, compared to the way Fabric defines domains. So you think of Purview as domains of doing a little bit more, and then the domains in a Fabric, because the Purview can actually have not just analytical data, but operational data in there. And it could track everything is done in your application in there. So more than you would see within Fabric, which is just the analytical data on that. So Pete Hine created a great blog that goes through how to use both Purview and Fabric to build out your data mesh, or even a lakehouse that is sort of like a mesh, but with a lot of exceptions. A lot of what I talked about today is in my book, and I always make this offer for people who attend the presentation is if you want a free copy of the book, just email me and I'll send you the full copy of the PDF so you can learn more than what I covered here today. And I left at least 4 minutes of questions on here. Looking at the chat, I said put stuff in there. I love my pancakes with Homer Simpson. People are talking about the hype of data mesh, which I completely agree. And Gartner had this hype cycle, and sometimes I show this in the presentation where the data mesh is recently was at the height, but now it's a trough of disillusionment, and it's definitely gone down there. And within Microsoft, we do see people building out a data mesh, but as I said, everybody's exceptions to it. And I listed some of those in there. And I think over time, what you'll see that I'm more of, which I'm currently seeing now, is a lot of people focus on data as a product. No matter what solution they're building, they're trying to set data as a product up, and they usually do that with semantic models in Fabric. And you get somebody who's a good modeler who creates those semantic models in there and makes it easy for people then to pull data out of Fabric, which those models, those semantic models, could combine data from multiple domains in there. So that could be that's I found to be a great approach, and what I think will continue to get to be more popular. All right, let's see. Got 2 more minutes. Any other questions? Just popping them in there. Yeah, and a good comment by Arno again is data mesh is trying to solve a lack of responsiveness and governance in a centralized architecture in there. And that's where I mentioned I initially had a lot of pushback on the data mesh. When I first read the book, I said, well, this is a great idea. But then as I started thinking more through it, I said, this reminds me a lot of what happened in the 90s with the Kimball versus Inman arguments. And do I create data marts that are copies of the data that's been centralized into these data marts? And in Kimball's architecture was you didn't have a centralized data warehouse. You had all these data marts, and they were logically combined together. And I find a lot of companies did it that way. And the data marts were created by each of we didn't call them domains at the time, but each of the organizations. And that worked very well. But then what you'd find is sometimes a new CIO or CTO would come in and say, well, why do we have all these domains with their own teams building these solutions? We can save costs by centralizing all of that into one IT team, which then the push became back to centralization. So we've been through this decentralization, centralization before, and I feel like we're going to wind up doing that again, where people are going into this data mesh and they're finding how much extra it costs to have their own domain teams. And then you may say the pendulum may swing the other way again when people say that's just too costly. But fortunately, a lot of customers are anticipating that. And most people who are building the data mesh are still having centralized teams to reduce the cost and the complexity and challenge of having each domain go and build their own thing. All right, thanks for that link, Kevin. Yeah, the pendulum between top down and bottom up. And again, I cover that in my book. So if you want to know more about the top down and bottom up approach, send me an email to get the PDF. Yeah, and Christian brings up another great point. Mesh architecture in a company is bad data strategy, and collaboration is the highway to data silos. So that's what's going to happen, which again happened in the Kimball method. Is a lot of people went and did their own thing, and nobody knew they did their own thing. Imagine now if you have a data mesh and people are creating that, and you don't realize somebody created their own data mesh in there, or they take the opposite approach and they go, I'm not going to build a data mesh in there. You centralize it, and so you're forced to have a centralization in there. But the problem is each domain is now doing things on their own, and initially they may support everything that is related to the data mesh and follow all the principles, but then over time they may start doing their own thing and forget to tell the central team that's tracking all this what they're doing, and then you have all these data silos, and you're in a worse off position. All right, Excel hell. Yeah, great. So I'm glad that people are realistic about data mesh and are seeing the same things as I saw. Like, well, this sounds great in theory, but I can see a lot of problems, and that's where there's been a lot of pushback from a data mesh, and just why we haven't seen a large amount of adoption of it. All right, cool. That's all on my end.